Hi student, this is the continuation of the first video. What we discussed, just brief about uh, the microprocessor and microcontroller difference. We can come to know that architectural viewpoint of hardware and von Neumann technology, and as well we came to know the embedded system where we are using the microcontroller and different applications where we are discussed. So the next will concentrate on the particularly on microcontroller. We are using the 8051 microcontroller. We just see the architectural point of 8051 or the features of 8051. So today's sessions we are discussing about features and pin descriptions, and if we have, we'll go with the block diagram of 8051. So the next we'll see that what are the main features of 8051. 8051 it is introduced by Intel, that is referred as MCS 51 microcontroller system 51 in 1981. See, 8051 it is basically a 8-bit processor. How we can say it is an 8-bit processor? See, any processor, it operates on data, so that it can be operated, the maximum bit size, it is 8-bit. So that's what it is, an 8-bit microcontroller. If the processor works on 16-bit on data, so that is a 16-bit processor. If the processor works on 32-bit of data, so that it will be a 32-bit microcontroller. For example, in ARM controller, it's also 32-bit microcontroller because it works on 32-bit data. So the next, see, this CPU can work on only 8-bit of data at a time. That's what it is, an 8-bit processor. The 8051 became widely popular after allowing other manufacturers to make and market any flavor of 8051. So we'll see some of the main features of 8051. It's an 8-bit processor, as we know that, and it has an internal memory and external memory. So internal memory, it is divided into ROM and the RAM. It has 4 kilobytes of internal ROM, as well 128 bytes of internal RAM. Remember, 8051 it has in 4 kilobytes of ROM and 128 bytes of RAM. In ROM, see, we can store our data, as well we can read only the data in the ROM area. So if you want to use a general purpose area to data store and retrieve, you can use a RAM. And we have the 4 8-bit IO ports. So let's say P0, P1, P2 and P3. We have each has an 8-bit. All ports are 8-bit. So we referred as P0.0, P0.1, so like this until P0.7. So these are all totally we have each port have an 8-bit. So one more information, this is a bit addressable. So that's what 4 into 8, it is, we have 32 IO lines. And if we here we have one more other feature says it's a 16-bit timers and counters. Here we can use T0 and T1 are the timers. These we can use as 8-bit also, so that we can refer as TL0, TL1. These two, timer low and timer, and similarly TH0, TH1, timer high. So these registers are 8-bit register. Combiningly, we can work with 16-bit. Next, we have on-chip full duplex UART for serial communication, universal asynchronous receiver transmitter. So how this will be works? See, this is my transmitter. It is a receiver as well as the transmitter. It can receive at the same time as well as it transmit at the same time. It is we called as a full duplex. So in that we have a half duplex, so that one time only it receiving, another time after receiving it can be transmit. That is in half duplex. So the next we have the 5 vector interrupts. We should remember here we have the 2 external interrupt and 3 internal interrupt, timer 0, timer 1 and serial communication. See, in the 2 external we have that INT 0 and INT 1, 2 interrupts. That is external interrupt. Externally we can give the interrupt, and we have the 3 internal interrupt. These 3 internal we can do by programming: timer 0, timer 1 and serial communication. Okay, next this is the one most features in 8051. It is an on-chip clock oscillator. Any processor works on the clock with the optimal frequency. So we need not to generate a oscillator. We need not to generate a clock by using your oscillator. So it is an on-chip oscillator. Probably we are using the crystal oscillator with the frequency of 8 megahertz to 40 megahertz. It depends upon the processor. So probably 8051 we are using 12 megahertz frequency, crystal frequency. And one more another feature says any processor. See, we have an address line. AD02. So let me take only the address line A02, A15. So totally we have 16-bit address line, so that it is 2 power 16. Totally it is 64 KB. of external memory we can connect it to the 8051. So in that we segregated two external memories. One is we have the code memory to store our code, and another one we have the data memory, so we can store the data into that memory. So totally it is we have the 64 external code memory and 64 external data memory. So it is separate memory. It has separate data line as well as the address line to access the code as well as the data. So that's what this architecture we call it as hardware architecture. The next point is it has a 16-bit program counter. As we know that to fetch a instruction, it means that it holds an address of the fetched instruction. So this is the 16-bit program counter. So this will be used to access the code memory, means that it accesses the instruction. And one more we have that to address the external memory we have 16-bit data pointer. So that is what we call it as DPTR, data pointer. It is a 16-bit. It can be similarly we can use for 8-bit and 8-bit. So that is one DPL and another one DPH. It is an 8-bit, lower 8-bit, and this is the higher 8-bit. So as that the RAM, it is 128 byte. RAM is 128 byte, so that we have the 120 user defined flags, and as well we have 32 general purpose register, each of 8-bit. See, this is we call it as register bank. So R0 to R7 each bank we have in that. So totally we have the 4 bank. So that's what 4 into 8, that is totally we have 32 total general purpose registers. So in that we have the working register, some of the bit addressable memory area, and we have the general purpose memory area, that is also we call it as scratch pad memory. And along with that one of the other features is ALU can perform arithmetic and logic functions on 8-bit variable, and we have the 8-bit program status word, that is what we call it as flags. So it is 8-bit PSW, program status word, and also 8-bit stack pointer. It has an 8-bit stack pointer. So as we discussed, it is a total 5 vector interrupts, but remember, reset is not a interrupt. It is not considered as an interrupt. So these are the main features of 8051. So in 8051 we have so many families. Subset of 8051, 52. We have 8031. It is a ROM-less 8051. Add external ROM to it. We can add the external ROM to the 8031. So here we can lose the 2 ports and leave only 2 ports for I/O operations. So the difference of some of the 8051, 8052 and 8031. So we can see that the ROM, whichever it is present on the on chip, 8051 has a 4K, 52 is in 8K. 8031 we can add the external, not internal. So that is a one difference. So the RAM, what we can define the totally the registers, working register or bit addressable or general purpose area. So 8051 has 128 bytes and 8052 is 256 and 8031 is 128 bytes. So 8051 has 2 timers, 8052 is 3 timers, and similarly 8031 is 2 timers. So I/O pins, that is the ports, we have P0 to P7. Probably we have 4 ports, so that's what it is. 32 I/O pins, all are 32 I/O pins. And serial port, we have everyone 8051, 8052 and 8031 as single serial port. So we have the interrupt sources. 8051 has a 6, 8052 is 8, 8031 is 6. So this is a brief difference of 8051 family. Next we'll come to the pin description of 8051.